Bum, 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 bum. Okay, this is the video that is going to either get you more involved in blockchain or it's going to make you quit blockchain. Nah, just kidding. I hope that if you're watching this video, you don't quit, because if you quit, you're a loser. No, you don't quit on your goals. You stay and you stick to it. Okay? I'm watching you. So, this video, I am going to give you either nightmares or I am going to give you sweet dreams. No, I'm just kidding. I'm just kidding. What I'm going to show you is I am going to show you how to do Chainlink VRF integration. Okay? What we're going to do, I'm sorry, just laughing. What I'm going to do, I am going to show you how to integrate Chainlink VRF so that we can start obtaining those random numbers, right? We need to get those random numbers because we need to make sure that our application is not compromised by some smart individuals obtaining the numbers, our winning numbers. We don't want anyone obtaining those winning numbers. We want to make sure that those numbers are not going to be obtained easily, okay? So with that, I am going to be integrating Chainlink VRF, right? We are going to be grabbing the information out of the Chainlink VRF. And when I say grabbing the information, I'm not saying that we're going to go to Chainlink ourselves and get the information from Chainlink. No. You know what we're going to do in this tutorial? I am going to be integrating the Chainlink VRF consumer smart contract, or in this case, the function is like callback. If you don't know what a callback function is, it's basically something that will be embedded onto the contract, or in this case, onto an application that will be used to obtain information from another source, or in this case, from another function. I need to call something external, right? There's a function that is outside of the platform, and I need to integrate some interface or a particular line of code that's just going to talk to that external source, right? And you are going to see how can we do the Chainlink VRF integration by placing the key hash and placing the smart contract address of Chainlink's VRF service, right? For each blockchain mainnet or testnet, there's going to be a particular smart contract address. So we need to implement that. We need to tell our smart contract, hey, by the way, if you need to talk and if you need to get this information, please go here, because that's where you're going to obtain the random numbers, right? So what we're going to do, we're going to add that into our smart contract. So then you see how it's easy to get random numbers or information out of Chainlink into any smart contract. We'll do that. Once we're done with that, we will show how to sort those numbers in order, because we need to have the array sorted in order. We need to make sure that every single number that is in that array is in order, because as you saw in the previous video, I make sure that the numbers are in order because we need to hash them in KeyCack256. So then we avoid having the loop checking every single number and comparing those numbers against the winning numbers. Instead, what we're going to do, we're just going to encrypt those numbers in KeyCack256. And when I say encrypt, encrypting is one, it's a valid term. Also hashing, we are going to be basically storing that, or we are going to be encapsulating that in KeyCack256. This will generate a hash. I just need to make sure that the hash matches, which tells me that the same values are on both the ticket numbers and the winning numbers. That's what we need to make sure that we have, right? So for that, I need to make sure that we do bubble sort. So with bubble sort, no, it's not blowing bubbles. That's not what I'm going to do. What I'm going to be doing is a function called bubble sorting, which what's going to do is going to check first number against the second number, right? Is the second number lower than the first number? If so, then let's flip the order of those numbers. That's literally all the bubble sort is going to do. It's going to flip the position from the first number, which one is lower. If the second number is lower than the first number or is less value than the first number, then flip the positions. And we are just going to continue doing that until we have everything in order. That's the bubble sort. That's all it does, okay? It's basically a double loop. It's one loop to go over every single value. The second loop, what I'm going to do, flip them. That's all we're doing, okay? So we are going to be doing those two things. Once we're done with that, then we'll test. We'll add some numbers. We'll make some calls into the smart contract. We'll get those numbers and make sure that the numbers are obtained in order, right? We'll call Chainlink VRF, which means that we also have to do a subscription We have to subscribe because Chainlink is a subscription service, which means that the moment I mint the smart contract or I deploy the smart contract onto the blockchain, I need to first provide the subscription ID. When we open a Chainlink account, we will get a subscription ID. Okay, so we'll get that subscription ID, we'll paste that subscription ID, and we'll deploy the smart contract. We deploy the smart contract. Let's do some test calls. Let's test the smart contract and see if we can obtain the random numbers. And I'm going to show you how can you modify the information on the smart contract to obtain more than X amount of calls. So every single call to the Chainlink VRF is going to give us a one random number. It's 72 digits, by the way. It's 72 digits in size. So what I'm going to be doing is I am going to obtain every single number, and from every single number, we'll do a simple math formula to get a possible number in a range of X amount of digits. And the formula is super simple. We're just gonna grab the random number, which is 72 digits, and we are going to apply a percentage, and the percentage number is the range in which I want to obtain the number itself. So let's say I want to obtain a number between 0 and 20. I will be then calculating the random number value obtained from Chainlink VRF, percentage, then 20. Then that is a very basic math for us to get a percentage that is going to fall in that range based on that long hash number or the hash value or the number that we obtained from Chainlink. Once we obtain that, guess what we need to do? Ideally, you want to do the following. If we need 6 numbers, right? I don't know how to count. We need 6 numbers, right? We need to call Chainlink, or we have to tell Chainlink VRF, give us 6 different random numbers. And when I say random numbers, it's the big 72-digit random number, okay? And they call it random words, but it's numbers, okay? So we're going to tell in the function in Chainlink that we are going to call for 6. So Chainlink is going to give you 6 numbers every time that we call the function, right? So we'll do that. And we'll also sort the numbers in JavaScript, because remember, I need to make sure that you are working efficiently. And when I refer to working efficiently, I am referring to the calls in the blockchain. I am going to avoid doing loops in the smart contract because those loops are expensive, they're pricey, right? So I am going to sort in order the ticket numbers from each player. So each player, I got into the application, I decided to buy a couple of tickets. I will send those tickets onto the smart contract, to register them in the lotto in order. So before I even store them in the smart contract, I'm going to put them in order. So then that call is done off-chain, which means that it's going to cost less to process. And what am I going to do with that? I am going to encrypt that in KeyCache 256. So we'll do that, and we'll implement the bubble sort in the smart contract. So then the winning numbers, once obtained from Chainlink, we can sort them in order and then hash them. And with that, I can compare both values. Okay, we'll do that. This will be video number 1. Video number 2, we are going to implement the rest of the lotto functionality. There's like 3 structs. Get ready. We talked about structs and what the struct. Okay, so the what the struct is on this one. We got a couple of struct that we have to store. We have to store the struct that includes all the draw information. We have to store the draw tickets, right? So for every single draw, we'll have to store the ticket numbers so that we can confirm that those tickets were purchased during that draw. Another thing that we have to store on the draw is the jackpot. If the jackpot was not claimed, meaning that no one bought a ticket that was the winning ticket, there's no winners, I have to grab the jackpot value and transfer that to the second draw. That's the whole purpose, right? To keep increasing that prize pool so then we have a more exciting game. We'll make that happen and we'll go from there. Now let's make this happen. Let's start by configuring the subscription. We are going to head into a VRF. So this will be the Chainlink's VRF site. And we will start by signing up with our wallet. And this will be the administrator of the subscription, okay? So I have my wallet selected already. It's already connected. And I am going to be interacting with the Polygon testnet, in this case with Polygon Mumbai. Okay, so you select your testnet, you connect your wallet, and then we can go ahead and create a subscription. So let's go ahead and create a subscription. Okay, so it's going to ask me the address that will be the quote, the admin of the account. And I have my address. This is the one that is connected to the browser. Okay, so we're gonna create a subscription. Now it's going to ask me if I want to approve. Of course I do. And we'll just wait to get the approval. Okay, let's wait. And we got the subscription created, has been confirmed. Okay, awesome. Now let's add funds. So in order for us to pay the Chainlink subscription, so we have to deposit link, and this will be the Chainlink token onto the subscription. So this will be deposit onto the subscription. So what I have to do, I have to head into the Chainlink faucet to get some test tokens, okay? So let's go ahead first. You can head into the Chainlink faucet, just do a quick Google search for it, and I am going to request some test tokens. So what I'm going to do, let me use this wallet. This is the wallet that I want to deposit those tokens. Save. I'm going to go ahead and copy that and paste, and I am going to verify. Okay, I'm going to send those test tokens, and let's wait. And I should obtain those test tokens, and let's see if we can see those tokens. Okay, let me go ahead and add the token because I don't have it on this wallet. We should be able to see the token. There you go, and I got my 20 test link tokens. Cool, awesome. Now I am going to deposit those tokens into my subscription. So what I'm going to do now, I'm going to add funds. And yeah, let me just add 20 because I'm going to be using that. So I'm going to go ahead and confirm the transaction. Let's wait, and off we go. Okay. And sure enough. Okay. So the subscription, let's go into my subscription now. And I have my subscription. It's going to be 3531. This number is extremely important because this has to be assigned into the smart contract. So then the smart contract can talk or interact with the VRF. Okay. So let's continue. Awesome. We have the subscription ready to go. Let me build that smart contract. Let's build a smart contract. So as you know, we got to add that license info at the beginning. And we go ahead and paste. Cool. And the Solidity compiler version. Okay. So we got that. Now what I have to do, I am going to be importing two things. I am going to be importing the VRF consumer V2 base smart contract, and I am going to also import the VRF coordinator interface. Basically, those two are needed for us to interact with Chainlink. It will provide me the connectivity to the Chainlink VRF and provide that interface between our smart contract and the VRF function. Okay, so I'm going to go ahead and paste right here. I think it's a little bit big. I think that's good. Awesome. Cool. So now I am going to effectively build the contract. Contract into the Lotto is a VRF consumer base too. This is how we inform or we import that into the contract. So we are going to be dealing or interacting with this particular import. And yeah, let's start writing. This is the end to the Lotto smart contract. Okay, let's build the entire Chainlink VRF. Okay, so I'm going to explain everything step by step. How do I associate the consumer to the interface, right? So what we need to do is we need to label the VRF coordinator to be the VRF consumer base, or we are associating the VRF consumer to the interface. And check this out. What I'm going to do, I'm going to type a VRF coordinator interface, and we're just going to call this coordinator. Okay. So basically, every time that I invoke this, it's basically going to interact with this particular import. So this interface import that we just did in the top. Okay. So this is basically the coordinator, and I will be using this variable to then use it as my calling object. So what I'm going to do now, I will be building the most critical things in the Chainlink VRF interaction. are the variables that we have to declare, which are going to be number one. So I'm going to go ahead and start copying and pasting, which you can see because it's going to be faster. So the first thing I'm going to do, so I need to provide the subscription ID because that needs to be sent to Chainlink so then it can do the call to the right subscription, okay? The VRF coordinator. Okay, let's discuss this real quick. So the VRF coordinator, it's basically me telling Chainlink which smart contract in the VRF side am I going to be interacting with, or in this case, which mainnet or testnet am I going to be asking for those random numbers. And they will have a VRF coordinator per blockchain, in this case, per mainnet or testnet, okay? So I have the value for the Mumbai testnet. If you want to know the values for all the others, let me show you. If we scroll under docs into VRF v2, let me show you, okay, subscription supported networks, and sure enough, okay, so in the supported networks, I want you to send the request to this VRF coordinator, and the smart contract is just going to make a call to another smart contract, in this case, the coordinator, okay? So with that said, let's go back. So I'm going to go ahead and add the address for the Mumbai testnet coordinator, which is right there, and again, in the docs, you can find the address for each one. Now, we are going to add the key hash. So the key hash, as a matter of fact, I am not too sure in the key hash. What's that about, right? So let's see. Key hash is the identifier that maps a job and a private key on the VRF service. It represents the specific gas lane. Okay. If you are going to be handling more requests, I will assume that you are going to increase the gas lane, and I'm going to be configuring that in a bit, but that basically it's the key hash, okay? Cool. So let me go ahead and declare that. Now let me declare the confirmations. So the confirmations are basically how many confirmations I'm going to request to confirm that I did have the information obtained from Chainlink. So basically, this is default. I am not changing this. And so in fact, I did up to like 100 random numbers in one transaction, and it worked just fine. So, and this is a very important, the num words. So this one right here, it's the amount of numbers that I'm going to be requesting, the amount of random numbers or random words, okay? From there, we are going to create that percentage calculation that will give me the number. So the number in the lotto, or every single winning number, is going to be obtained this way. But this is to give me that random long number that we will obtain from Chainlink, okay? Cool. So let's say you have a NFT collection, right? And you want to make the NFT collection mintable in a random order, like there's no specific order. You can actually use this, this feature right here, this Chainlink VRF, to generate a function that will mint random IDs. And you basically will request X amount of random words per amount of NFTs. So if you have 3,000 NFTs in the collection, then you are going to request 3,000 because you want to generate one random ID per request, okay? And the callback gas limit, this is what we are going to tell Chainlink, hey, charge me up to this amount in gas for this transaction. This is not executed by the wallet. It's executed with your funds in the Chainlink VRF account in the subscription, okay? So those 20 link tokens that we just deposit into that subscription, from there, they are basically charging us the gas fee. And we tell how much is the maximum. I believe this is the max. So 2,500,000, it's the max, and the limit, I was able to obtain up to 100 random numbers in one transaction, okay? That's kind of cool. And this will be the owner of the subscription, or in this case, the address that will do this request. And usually it's going to be the owner of the smart contract, is basically the one that is going to interact with Chainlink. And that's what we did with created the subscription using the same account that we're going to be using to deploy the smart contract. So now in the struct, so this struct is provided by Chainlink. Basically what they're expecting to store is the result of either is fulfill or not fulfill. It does exist, and the actual random numbers or random words. Okay, so this is where we are storing the values. When Chainlink will send that value back to us, we will store this in the request status, and this will be called to obtain the numbers. Okay, this is just a struct storing that data. And I am going to be adding two additional declarations. One is going to be a mapping that maps the request, right, to the struct. So basically, this is the request. This will have a unique ID, and the ID will then give me the values, in this case, the random numbers. So every single request will have an ID. If we want to get the values from request number 2, we just send that call to this mapping 2, and then it should give me the words obtained in that request, okay? And then we will track the last request ID because we are going to be doing some fancy things with that, and you're going to see that later, okay? And now we are basically doing the constructor. We are going to ask when we deploy the smart contract, we are going to say, hey, by the way, give me the subscription ID. Okay, very important. And let me just do it this way, subscription ID. And this is when we deploy the smart contract, you're going to see that we are going to provide the subscription ID. Okay, and we will then import the VRF consumer base smart contract. Okay, and we are going to associate that to the coordinator, okay? And we are going to declare right here, VRF coordinator, okay? And finally, let's go ahead and initialize those properties. So we are going to, remember we declare coordinator, now we have to provide the value to the coordinator, which is basically the VRF coordinator interface, okay? This interface is going to have what? The VRF coordinator's address. Which one is the VRF coordinator address? You see it right here. This is basically telling Chainlink, hey, this is in Mumbai. This will be the Polygon testnet, okay? And now we are going to declare that the S owner, remember we declared that long ago, we initialized that long ago. It's going to be message.sender. It's going to be the wallet that deploys the smart contract, okay? And we are also going to declare right here, expecting that subscription ID, so then we can store that under subscription ID. So whichever value do I pass, it's going to be stored in this var that will be used across the functions, okay? Cool. So we got all the initial settings in the smart contract. Now what I have to do, add a function, right? The function that I'm going to be configuring now is to request the random numbers. We are going to call this function. And by the way, we have to deploy the smart contract, and we will have to deploy other instances because we're going to keep adding functions. But I just want to show you what we need to do. There's going to be the first function that we are going to configure. It's going to be function close lottery. Okay. This function, when we execute this function, we are going to request to Chainlink those random numbers. Okay. So let's say closed lottery, it's going to be an external function, and it can only be called by the owner. In this case, the wallet that was used to deploy the smart contract, that will be the owner wallet. I have to also import that smart contract or that interface. Okay, so let's import that. Okay, so let's go ahead and import that here, ownable. And now I got to say it's a VRF consumer 2 base, and I also have to declare it's ownable. So then I can use that function, okay? Now I can restrict this function to only be called by the owner of the smart contract, which is very important because this is how you close the lottery, right? Well, this is how you close the draw. So every draw will be closed using this function. The first thing that I'm going to do, I am going to store the request ID, okay? We have to store this because we're going to be using that during the function. We are going to say now request ID. It's equal to the coordinator because we're going to be calling Chainlink, and we're going to say request random words. Okay, this parameter right here is inside the coordinator. So that's why I'm invoking coordinator, because we declared coordinator, which was part of this interface. We're bringing that interface in from this import right here. And now we are calling this particular function, which is inside that import, the import interface that we did, okay? Okay, so now I have to say the following. I am going to be providing all the parameters that Chainlink is going to expect. So key hash is going to be one of them. And we already provided those values in the beginning of the smart contract. We have everything already declared. We don't have to like tell what's the key hash because we already stored that in the smart contract when we initialized it. Then it's going to be as subscription ID. We are going to provide the subscription ID. We are also going to be providing the confirmations. We want to tell Chainlink, give me X amount of confirmations so then I know that we have the request, okay? Callback or gas limit, because we're going to tell Chainlink how much gas I'm allowing to charge in this transaction. What's the maximum, the cap, okay? And finally, send me those random numbers because I need to have this amount, okay? So I am going to tell, give me 6 random numbers in this transaction. This is where we are going to make that call right here, okay? And now we're going to say as request. This is the struct. You remember the struct? As request, that's the struct. Right here, this is the public mapping to the struct, and we are going to store whatever we obtain from that. And request ID. So remember the request ID that we just did right here, we're going to store that inside here, and we are going to say that this is equal to the request status. That's the actual struct. This is what it's inside here. Now we are going to get all this information, right? So why am I going to make it? Let's make it more simple. Let me just copy this because this is exactly what I'm expecting inside here, okay? So I am going to declare the following. I am going to say, now I have to provide those values, right? So what I'm going to do, I'm going to say fulfill random words, okay? I'm going to say fulfill hasn't been filled yet, okay? I'm going to explain why, because there is going to be a callback function. Remember at the beginning of the video, a callback function that this is just going to send that to Chainlink. Chainlink, once it provides me back, then we will change this to be true. So that's where we update this to be true. But right now, the request is still false because Chainlink is not giving me anything back. Okay, so we're going to say that is exist, true. Does the request exist? True, it does. And then the random words. What am I going to expect there? I'm going to be expecting an array, UINT. That's what Chainlink is going to send me back. Make sure that you declare this because Chainlink should be providing me that array right here. Inside this array, we are expecting the values from Chainlink, okay? And that's good. Okay, and now that last request ID that I declared at the beginning, I am going to just say that the last request ID was this request, the one that we just executed right here. And that, ladies and gentlemen, it's the call to obtain the winning numbers, okay? We are just going to obtain the winning numbers. But we haven't done the formula to get the percentage so then we can get the particular values. We're just going to get this long random number, okay? Now we are going to add 2 functions that are callback functions that Chainlink expects. So this function that I just configured right here, this function, it's only relevant for our Lotto application, right? The 2 functions that I'm just going to paste below are Chainlink default functions that expects you to have, so then Chainlink can tell you back the information, can send you that information back to you, okay? So what I'm gonna do, I am going to make it simple. I'm gonna copy and paste so that I can go over every single one of them, okay? So let me just go a little bit smaller here. I think it's good if I do this. Yeah, there you go. Awesome. So now I am expecting to obtain the response from Chainlink under request status. When I call this function from my smart contract, I should obtain those random numbers, okay? I am going to obtain the result, which is either is it fulfill or not fulfill. Until Chainlink gives me back those values, this should still tell me that it's false. When Chainlink is able to send me the information back, this will change to true, and then we will get those random numbers, okay? So we will get this, make sure that it exists. Remember when we initialize the call, we have to call this first, so then this is initialized, and we have true. If we go back here, remember, it's expecting me to have this to be true, or else request is not found. If it's true, then we are expecting that request. Hey, give me the request. If we obtain that request, we are just going to call the struct right there and obtain the random numbers. That's basically it. And the other function, right, this function right below, it's going to give me the random numbers itself. This is the function that Chainlink is going to be calling. It's going to be an internal function that Chainlink is going to be accessing to give me those values back. This is where we get that callback, that we get that information back into the smart contract. This is kind of cool, okay? So with that said, I am going to deploy this. There's another function that we have to configure, but it's not related to Chainlink. I am going to deploy this, and we're going to request some random numbers. Then we'll go back and we add the bubble sort. We wanted to add the bubble sort so then we can sort the return after we do the entire calculation. Okay, call this N2 the lotto because it's the N2 the lotto. So, and let me go ahead and paste. And let me show you right here what we got. Cool. Now, yeah, this looks good. Okay, let me Control S and see if we run into an issue. We do. Let's see what the issue is about. And I bet I'm missing this right here. Okay, here we go. Yeah, you know what? I forgot some syntax here. This will be in brackets right here. I think that should do it. There we go. That looks better. Control S and boom. Awesome. Now select the wallet and we have to now provide the subscription ID. So let's go ahead and provide the subscription ID. And remember that subscription ID? It's going to be 3531. We're going to add 3531. Let's add that right here. And let's go ahead and deploy. We should get the prompt. We do. I'm going to confirm. And we got the transaction. We got the smart contract. Now, very important, we have to add this smart contract address as a consumer of the subscription. So I have to copy the address. I'm going to go back to subscription, and we are going to add this consumer under our subscription, okay? So let's go ahead and add the consumer, and this will be my smart contract address. We'll add the consumer, and now I should be approving that transaction, which I am. Let's wait for the confirmation. And we got the confirmation. Awesome. I'm going to close. We should see the first consumer added, and that consumer is there, and we got the balance right here, the 20 link. I am going to go to Remix, and I should be able to request VRF numbers. So let's go ahead and do that. Let me go ahead and hit close lottery. That's the request function. We should get the prompt. Beautiful. And let's confirm. Now, once it's confirmed, let's head back to the VRF and see if, there you go. I think I got a confirmation. Boom. And now let's head to the VRF. Let me refresh. And sure enough, we are looking very good. Okay. Now we are pending for 10 seconds and we should see here to have a fulfillment. So it should be fulfilled. If we go back, we should get that fulfilled. Okay. We're done. Awesome. So we should obtain those random numbers. Let's go back to Remix and let's get the request status. Remember the function right here? Let's request. Beautiful. There you go. Now we got the random numbers. Now, if you can see, I'm going to do my best to zoom in. If you can see, every single request will have a comma. So request number 1 ends here. Then request number 2 goes here and so forth. So we specified in the smart contract 6 random numbers. Or 6, yeah, random numbers. So that's what we have, okay? So now every single value, I am going to get those values and I will be converting them into the unique. I'm going to obtain those unique numbers and those will be my winning numbers, okay? So let me go ahead now and build additional functions in the smart contract. We are going to be adding the function to get those words, convert those words into the winning numbers, and then sort them in order. We're going to be doing the bubble array sort function in the smart contract as well. Okay, cool. So let me zoom out. Beautiful. This is beautiful. Now let me go back into the smart contract. We have tested this smart contract. Now we know that what I have to do, I have to send now the values to be converted into the winning numbers. So what I'm going to do, I'm going to do a test function for now, because in the next video, we will be integrating the rest of the Lotto functionality, okay? Function get winning numbers, okay? And we are going to call this to be external, also only owner. From here, we are going to use those values. We're going to be using those values, and then we will generate our winning numbers. So the first thing I'm going to do, I'm going to store what I obtained from Chainlink into a variable here, so then I can get each individual random number, and then we'll do the percentage. Okay. So the first thing I'm going to apply or add, it's going to be, I'm going to create a new array, and then inside that array, I am going to store all the requests, okay? And then from the array, I can call each individual one. I have 6 total random numbers requested, and we will store all that in the number array. Now what I got to do, I am going to be declaring one by one. So I'm going to say UINT, I'm going to say number 1, okay? We are going to then declare the following. I am going to say num array, and what's the first random number? 0. So remember, in the array, the first position or the first value is 0. Then we will apply that percentage. What percentage do we want to apply? We want to say 1 to 20, or in this case, 0 to 20, right? Okay, so I got this. Now I'm going to just obtain the other ones. I'm going to say 2, 3, 4, 5, 6. Cool. So we got 6. Now we're going to say 2, 3, 4, 5, and 6. Cool. And now we're going to say 1, 2, 3, 4, and 5. There you go. Awesome. So now we are using every single value that we obtained from Chainlink, every single request, numWord request right here. We will use that here, and we will obtain those winning numbers, okay? Now what I'm going to do, I am going to send that output as final numbers. So what I'm going to do, I'm going to create another array, but this time it's declared with 6 values, and I'm just going to populate every single number inside this one array. This right here, we can use that to display in the front end the values, or in this case, the winning number. So we can read that, because what we are going to do, we're going to store this value in the struct that is going to hold everything regarding every draw. So every draw, you know, the tickets that were sold, the winning numbers, the jackpot, all of that, we will store that in the smart contract every single time that there's a new draw, okay? In this case, we are just testing. So what I'm going to do, I'm going to return, okay? And we are going to return what? Final numbers. And because this is a view function, I assume and I hope that this will allow me to be executed without having to be a payable. So let's see if I can do that. So what I'm going to do now, I'm going to copy this. Let's add that to the smart contract and see if it compiles successfully first. I'm going to add it right here. And I already have an issue. What's the issue? Oh, return declaration. Okay, so because we're declaring a return, we have to say returns, only owner, then returns. And we are just going to say UINT 6 memory. This is the value that we are going to be returning. And we'll save, and looking good. Awesome. I have to deploy it again because we make a change to the smart contract, and we have to add the subscription ID one more time. And boom, deploy. Oh, not here. I'm going to deploy it in the Mumbai testnet. And let me go ahead and deploy. I have to pay. We should get the confirmation. We have to add this as the consumer once again, and we are almost done. Okay, we'll do this. We'll do the sort, and off we go. Okay, copy. Let me now add this as a new consumer. So what I'm going to do is add a consumer right here. Let's paste this new smart contract address. Let's say okay. And we're looking good. It's got confirmed. Now we should see that here as confirmed. Consumer was added. Cool. Awesome. Let me go back to Remix. And now we should have the smart contract ready for us. Number 1, I'm going to close the lottery so then I can request to Chainlink. I'm going to close. And now we should be waiting. Got confirmed. Now we should see that transaction pending. There you go. Transaction is pending. There's 6 numbers, okay? And it got confirmed, actually. That was quick. Okay, now get request status, and we should see those numbers. Beautiful. We got the numbers. Now let's see if the winning numbers function will actually give me the winning numbers. Look at that. Okay, so we can see right here that there was 2 numbers that were duplicate. We can work on making this more random, even more, but you can see right here, it's not a normal range of numbers. We got a number as low as 8, but then we have a number as high as 18. But now you can see that we obtain some random numbers, and those quote will be our winning numbers. Now the final thing that we have to do, we have to add another function to sort this, to do the bubble sort. Okay, and we have this here. Let's build the function in Node.js to do the sort array. And on the next video, we'll add the function into Solidity because we have to sort and order the winning numbers. Let's do it in Node.js because every single ticket that gets purchased in the app, we'll sort that ticket before sending it to the blockchain. It's going to be a gas efficient transaction if we do it that way, okay? And we don't want to be sorting every single number using the smart contract, only the winning numbers. So then we save some gas fees right there, okay? Okay, so we got the bubble sort JS. Let's pass the winning numbers, okay? And let's grab this and we will pass this into Node.js so that we can validate the sort array. So I'm gonna declare constant win numbers. And we are going to say this is an array. And we are going to just add those numbers there. Cool. And now let's build that function. The function is going to be called function sort array. Sort array, and we are going to do the magic. Okay, so I'm going to say it's for I'm going to say let I equals first. I, it's less than win number. So this is a total of 6. Then just keep incrementing, okay? So with that, I am going to say, first of all, I have to determine if the number was already sorted or not. So what I'm going to do, I'm going to say a Boolean here of, let's call this swapped. That's how I tell JavaScript, hey, that you sorted this already or not. And then once it's sorted, then we'll convert this to be true, okay? So we're going to say false. Then we'll run through the sorting, then we'll convert that to be true, okay? Now we're gonna say for, and we're going to say let. Now let's call this a. Let's say n as a number is equal 0 because we're gonna start with 0. And then we're gonna say n is less than what? Less than the same with numbers.length, okay? And we are going to keep incrementing n. I am going to declare let second. This will be the second number. We are going to store the second number. And what's the second number? It's inside win numbers. Remember, we start with current, which is 0, right? The first number in the array, or the first position is 0. The second position is going to be 1. So what I have to do here, I have to declare n because it's 0, the first one, right? And I'm going to say +1, which means that it's the second one. So the second, it's 0 plus 1, which is a 1, right? This will be here. As I go over the for loop, it's just going to keep incrementing n, right? So the next time it runs, it's going to be 1 plus 1 is 2, and that's how we are going to get every single value, okay? And now I have to just declare the first one. Copy, and I'm going to say let first. The first, which one is? It's 0. Okay, first is going to be the position 0, which is just n. Okay, now I'm going to say if second is what? It's less than first, do what? You know, swap them. I am going to say then when numbers n is equal to what? If the second is less than the first, then what I'm going to be doing now, you know that first is this. If second is less, then I have to put second in first and first into second. So I'm going to now declare second to be 0. Okay, then we'll do the next one. When numbers, now I have to move first into second. I'm going to say first n plus 1 is going to be first. You see? And I now have to change the state to be true. I'm going to say swapped equals true. Now, once it's swapped, let's continue checking every other number until I don't have any more declared to be false, right? Everyone has to match true. That tells me that I finished the entire array. So what I'm going to do now, I have to put another condition, say if nothing matches false, meaning that all the function was ran across all the values, then that means that you finished, which means that tell me return what? Win numbers. Okay. And as a matter of fact, this has to be let. The reason why it has to be let and not const is because I need to update this, make it const. I will not be able to update this value. Okay. It has to be let. So I'm going to say win numbers. And once you're done, hey, also return numbers. And that should be it. Let me go back and let's see if everything looks good. Yeah, everything looks good. Win numbers, so array, yeah, let's give it a shot. And we should see 8, then 11, then 12, 16, 18, 19, because they're both equal, okay? So what I'm gonna do now, I'm going to say, I am going to call constant output, and we are going to just say sort array. Now, once we obtain that information, let's console log it. Console log, and let's do console log output. And that should be it. Cool. Yeah, that should be good. Awesome. So let me go ahead and Control S and let's run it. Let's see how that goes. And moment of truth. Node bubble sort. Go. And let's see why it did not complete it. Okay. So it looks like it stopped n equals it like a start, but no, it did not. Actually, you know what? Oh, I know why. As I go over every single value, I have to decrease because it will just not run. It thinks that it completed, which means that it never started decreasing the amount of items that it has to go over the array. So what I have to do instead, I have to declare here to be I. Yes, to be I, because as I go over every single value, I want to make sure that I stopped the array from just continuing on. In this case, if I don't do I or minus I would not stop. So I have to stop it by lowering the length in the array. So then I know that I went through every single value right here. Yeah, that should be it. Let me format it to make sure that it looks good. It looks clean. Let me Control S and let's give it a shot again. There you go. Awesome. All right, cool. So now we saw that it was able to. We have to make sure that we keep decreasing the length so then we know that we went through every single value, okay? And you can see now 8, then 11, then 12, then 16, and then we have two duplicated 18s, but you saw that it was able to put them in order. Beautiful. Get ready. On the next video, let's build that smart contract. Let's continue building the smart contract. Now you know how to work with Chainlink VRF. I told you, now you know how to work with Chainlink VRF. Alrighty? On the next video, let's build the remaining functions into the smart contract and let's deploy the smart contract so we are ready to start working with the backend. In the backend, we'll do all the magic. We'll make this application 100% automated. It's just going to work on its own. It's going to open the draw. It's going to close the draw, request the winning numbers from Chainlink VRF. It's going to obtain the winning numbers. It's going to give us the winning tickets if there were winners on the draw. It's going to have the claim functionality. We'll build all that and we'll test it out. That will be video number 3. Okay, but on video 2, we have to finish the smart contract. Alrighty? So that's it for this video. I hope that you enjoyed what I teach you on this amazing tutorial. And hey, if you support me, I'm gonna ask you something. Subscribe. I need your support, guys. In order for this channel to grow and continue providing you amazing tutorials, hit the thumbs up. Subscribe if you haven't subscribed to. And as always, I'll see you in the next video. Bye.